What if I told you your router is making life or death decisions for every single packet, and that one wrong entry in its routing table could send your data into the void? In this video, I'll reveal how routers really work, from the 3 secret switching methods to reading those mysterious routing tables like a pro. Watch now to finally understand what happens inside that blinking box.
Routers have 2 important functions. First, they need to determine the path to forward the packets to, using their routing table. Each router keeps its own local routing table. This table contains a list of all the destinations he knows, as well as how to reach them. When a router receives a package, it checks the destination IP address and searches for the best match in that table. This can be a route that is directly connected to it, or the IP of another router's interface to reach the destination. If no entry exists for the destination network, then it will be routed to the default route. And if no default route is configured on the router, then the package will be dropped, that is, deleted. The second important function of the router is the routing of packages. After finding a match to the destination network, the package will be forwarded to a network interface. As this topology shows, each line of the routing table lists a destination network and the interface that allows you to join that network. If the destination network is identical to one of these interfaces, then it will be considered directly connected. For example, if router 1 receives a package on its 000 series interface bound for the 10400 network, then the package will be routed directly to the fast Ethernet 01 interface. When the package passes through a router, they say it makes a jump. For example, if router 1 receives a package on its fast Ethernet 01 interface bound for the network 10300, then in this case, it must transfer the package to the interface of router 2, which carries the IP 10101. Then router 2 will deliver the package itself. This will be very easy for it, since the destination network is directly connected to it. Routers support 3 mechanisms for packets transmission. We have the process switching, which is the oldest package routing mechanism. Each package requires a search in the routing table, which causes huge latency. Today, it is no longer used too much, at least in recent networks. We have the fast switching, which improves the latency of the previous mechanism. Here, routers use a cache to store the latest destinations. The first package whose destination is not found in the cache, it will be switched by the old mechanism, and an entry will be created in the cache. The following packages will have a faster switch because their destinations will be recorded in the cache, and the processor will not need to work to find the way. And the last mechanism is the Cisco Express Forwarding, which is the newest and most widespread mode. It incorporates to itself the best previous mechanisms. Here, each change to the network triggers an update of cache entries. That is, when something changes in the topology of the network, the change is immediately reflected in the cache. All packages are switched using the cache, even the first package, so this is the fastest transfer mechanism. A routing table contains a list of all known router networks and how to reach them. Each line of the routing table lists a destination network as well as the interface or IP address that allows you to reach it. In a routing table, you can find different types of entries. We're the one that's directly connected to the network. All networks belonging to the router are automatically added to the routing table. It is a network which one of the router's interfaces is part of. We have statics, roads. These are manually configured inputs on the router. It can be effective for small networks, and there is no huge change. On the other hand, if the topology of the network changes regularly, it may be very restrictive to the network administrator, because he will have to manually modify all the static roads on each router. We have default routes. If no routing table entry matches the package's destination network, then it will be automatically redirected to the default route. This prevents the package from going round in circles until it is automatically destroyed by its TTL. The TTL is a data placed at the header of the IP package that indicates the maximum number of transit routers. If this number reaches 0, then the package will be destroyed. And we have dynamic routes. The router can learn the roads automatically when a routing protocol is set up and a neighborhood relationship with other routers is established. Very useful on large networks. Or there are many changes. And this is what a router routing table looks like. The show IP route command allows you to display it. The first part of this output explains the codes associated with the inputs of the routing table. The letter C is reserved for directly connected networks. The letter L is reserved for local routes and indicates leases in networks that are directly connected to it. The letter S is for static roads. The small asterisk indicates a default route. In this example, the default route is a static route. Letter R is reserved for the RIP routing protocol. The letter O for OSPF, and the letter D for the EIGRP routing protocol.